and then the end objective. This game will end after all the orcs have been killed, or this game will end after all the coins have been utilized. So that is the story of the game. Yeah. And within the game programming, we learn other concepts like collision detection, how to program a collision detection, event handlers, how do you communicate with your game, how does the player communicate with the game. When you hit a key on your keyboard, what happens? Do you create a jump on your character? Yeah? Or a stop, let's say on your racing, on a car racing game? Those are called event handlers. And so what I was saying is that I'll give you, those of us who have already developed your game, you can present your game, then you get your marks. Then towards the end of the, or in 2 weeks time, we can have a sit-in cut. And then I'll allow you to now proceed and start preparing for your exam. But this should not end there, because the game programming is evolving. There are new things that are coming, like virtual reality, or the future of the game programming, things like virtual reality, roboting, or online games. So you can continue researching more about the future of game programming on your own, for your own good. So is that clear, Eddie?
Yes.
Yes, Patrick.
Does this, hello?
Yes, sir.
Yeah, does this mean we won't have like a formal presentation at the end of the semester where we'll be presenting our game?
Sorry, I didn't get that.
Does this mean we won't have a formal presentation of our games at the end of the semester?
No, because you are more than 70 in your class, so we may not have a time to have you presenting your games in an hour, or even 2 hours, or even a day. And because of that, what I said, like 2 students already presented. And based on the progress of their game, I know I'll also look at their game documentation. But based on that, I can still go ahead and award them the mark, because I've seen all the elements, tetrads of the game. So what we do in our class, every day when we meet, we'll be having at least 10 people present, so that in 7 sessions, we can have all of you having presented your games. So we have 40 minutes of classwork, then 15 minutes or 20 minutes of presentation. So that if you have not started, you can start. And those who have already started can go ahead and present. So that by the end, by the time you are doing your sit-in cut, all of you already have your project marks. So that is my plan. Is that okay with you?
Yeah, that's okay.
Okay, fine. So what is collision detection? Or why do we need collision detection in game programming? Your game needs to be logical. Yeah. What do I mean by logical? Is as I said, a game is a story. It's like writing a book. It's like telling somebody a story or a journey. Let's say I'm moving from Kasarani to town where I stay. I'll move from my house to Kasarani Road. Along the road, I'll meet, let's say I'm driving, I'll meet very many vehicles. So when I get into a junction, I need to stop and allow vehicles to pass. Whenever the junction is clear, I enter into the road. Then I go up to Roysambu roundabout. Then Roysambu roundabout, there are rules that govern how I should drive. Because there is a roundabout, I don't need to stop and wait for other vehicles to pass. I'll just take the left lane and enter through to the superhighway. Then I drive through the left. If I meet a vehicle that is moving slower than my vehicle, then I overtake that vehicle. Yeah. And then I move very fast. If I see a policeman, I hide if I don't have, if I've not renewed my license, or I try to run away. Yeah. Or I move to the speed lane so that I'm not arrested. Then when I approach town, what do I need to do? I enter into a junction. I wait for vehicles for the light. Now in town we have traffic lights. I'll wait until I see a green light. Then I move. I go and park. That is a story, and that is a game. And I can develop a game basically on what I've said. Yeah, and you can even borrow that, and then do your game as just a story of somebody moving from his house in Kasarani to main campus. Once you get to main campus, you have not caused any accident, you have not hit a vehicle. Or if you hit a vehicle, what do? You stop, you reduce, then you lose some points because now you've caused an accident. Then you sort out the accident, you proceed, you get to town. That is already a game. And so, where does now collision detection come in place in this game that I've described? One, when my vehicle will be moving, there will be other vehicles on the road. So I need to detect whether I'm coming too close to another vehicle. So if I come too close to another vehicle, what should happen? I need to brake. If I don't brake, then I need to create an impact or I knock that vehicle. When I knock that vehicle, definitely my vehicle will not continue moving, it will stop. Again, on the roads, there are barriers on both sides of the road. If I veer off and hit a barrier, what will happen? My vehicle will get crashed and then it will not continue moving. So to set these conditions on your game, then you need to apply collision detection function. Yeah. So that is for the movement. Somebody will want to do a game like the one that was presented last time, where a ball was moving and hitting the surface and bouncing back. That bouncing back aspect is a collision detection. I believe this gentleman had programmed in such a way that if the ball hits a surface, it needs to bounce back. It doesn't go through the surface going down, or it doesn't stick there. Yeah. Because we learned another aspect last time of animation, whereby you can create an illusion of motion using static images. And so now, that game employed both that principle and also the collision detection principle, and any other game that you'll have, even if it's a shooter game, even if it's a boxing game, there's that you can't develop a game without the collision detection algorithm. So collision detection is a fundamental part of game programming. It's the process of determining whether two or more objects in a game are either intersecting or overlapping. Yeah. So this is important for preventing objects from passing through each other and for generating a realistic physical interactions. Yeah. As I've said, your game needs to be realistic or it needs to be logical so that if someone is moving in your game, you should not move through or through buildings or through walls. If it gets to a wall, it should there should be that realistic aspect of I've hit a wall, so I can't go through. Either stop or bounce back. Yeah. So once a collision has been detected, the game engine can then handle it in a variety of ways. For example, the object may bounce off each other, or one object may be destroyed or die. Yeah, is that okay? Just a minute. Give me 1 minute. Okay. So this is the why we need to have a collision detection, because then you need to create that realistic of the game. Yeah. So what are the various types of collision detection? We have okay, this is how it works. This is a function of collision detection. Okay. Just a minute. I receive this call. Okay, sorry for that. So this is a function of a collision detection. As you can see, it's just checking whether two objects are intersecting or overlapping. If they're intersecting, then it will create a collision. If they are not, then it will return a false. Yeah. So this is basically a function where you are taking two objects with their x and y axis and measuring are they overlapping. If they are overlapping, then there's definitely going to create a collision, because it means when they get together, they're going to collude. Yeah. So this is basically a simple function of a collision detection. You just check if the rectangles overlap on the y-axis or the overlap on the x-axis, and then you either return a true if if they are colliding, or a false if they're not colliding. Yeah. And an example, you can create two rectangles with their dimensions as seen there. And then once you have their dimensions, then you can play, or you can, if you place them on your game scene, and if it's falling down or moving on a horizontal line, then you can check those axes based on the other object that is on the different side of the game scene, or if they are moving close to each other. Whether those axes are going to meet, then it's creating a collision. So this is basically a simple example of a collision detection function. When we'll be looking at programming languages or fundamentals of programming language, which I appreciate you've learned 3 or 4 years, we'll see how to create functions and how to call those functions in a game. Because if your game has very many conditions or rules, then all those rules you have to create them as functions. Like you have one function for collision detection. You have one function for maybe rotating an object. You have one function for event handling. Like if two objects meet, then what next? Yeah. Okay. So now, what are the various types of collision detection algorithms that you can use or you can apply within your game? Yeah. One of the collision detection algorithm is basically the bounding box or bounding spheres, yeah, or bounding objects, whichever you can call it. So this is an aspect whereby, or an algorithm whereby objects or spheres are put in boxes, yeah, and then you quickly eliminate those boxes that are not likely to meet. Like when you are putting your objects or people or spheres or any item that is moving, let's say your balls. What you do with this bounding box algorithm is basically creating some bounding volumes or boxes within your game scene, and then you check on your objects. Are those objects within this set of box or within this rectangle or within these four corners? So that if boxes or objects are moving, the only thing that you'll be checking, are they within the box? Are they within the sphere? Are they within the rectangle? If they're within, then there's definitely a collision. If it's outside, then definitely there will be no collision. And how do you achieve that? You use you check the intersection, just the same way we saw the algorithm up there. So here you put an object, and then you create the dimensions of that object. Yeah, like a box. You can have one side of the box, you give it a coordinate, let's say x1 of box 1, because a box has four shapes. But if it's a cuboid, then it will definitely have 6. So you have one corner will be x1, the other one corner will be y1, the other corner will be x2, y2, x. Then in box 2, you also have those coordinates. Those are the ones that we are calling bounding box. Yeah. So how does this algorithm works? You create a bounding boxes for each object, determine its maximum and minimum y and x and y coordinates, and z coordinates for a cube or cuboid. So this will define the corners of the bounding box. Then step 2 is to check if these corners intersect. Yeah. So you check if the bounding boxes intersect, then compare the corresponding coordinates with the other box. If the minimum coordinates of each object is less than the maximum of the other, then there is an intersection. Yeah. So that is one way of achieving that intersection. So first of all, before now you create an intersection, you need to create, as you've said, you create the coordinates of where you have placed your objects. If they are falling down, you can tell definitely they are falling in one direction, one vertical direction. And if it's falling down, then it means the y-axis, the x-axis will be changing, but the y-axis will be the same because it's moving in a straight line downwards. If it's moving in a straight line horizontally, then the y-axis will be changing, the x-axis will be the same. And now you can use that to test the detection, the collision. Yeah. And therefore, there are very many other ways of collision detection or approaches or algorithms, but the most common one is actually the bounding box. Yeah. But we also have the broad face or narrow face approach. So this separates collision detection into two phases, the broad face and the narrow face. And as you can see these images on the right here. So the broad face identifies the pairs of objects that are close enough to create a potential collision. Yeah. So you say this one is in the broad face and this is the narrow face. Then the narrow face performs a more precise collision detection of those two objects. So you first get the bigger face, or the broad face of that object that is falling. And then you predict where it's going to get to as it moves down. Then you can narrow it, then to test if it's actually going to hit each other or it's going to miss each other. Yeah? And this will be key for those people who are creating maybe the bouncing balls game. Yeah. And the other algorithm is called the spatial partitioning. So this is basically a spatial subdivision of okay, I don't know if I've learned sort and sweep. So the spatial partitioning is basically subdividing the portion of the space into grids. Let's say your game scene. So you divide it into grids, and then now you create cells on each grid, and each cell contains a list of each objects within that cell. So a collision test is set between the two objects if they belong in the same set. So if they belong in the same set, you've subdivided your space into very small grids. So if they belong in the same grid, then it means they're going to collide. If they're not belonging in the same grid, then they are not going to collide. So all these are different algorithms, but then they speak into the same concept of measuring an object is moving. Is it likely to going to pass through these coordinates? Yeah, coordinate XY or coordinate XYZ, and an object is moving here. So what we are doing, we're just trying to split the scene into very many grids. The other one, we'll split it into boxes. This one, we've split it into faces. And now this one, we're splitting into grids. But the concept is the same. Let's look at the sort and sweep. So the sort and sweep, in this approach, the bounding volume of each object is projected into the X, Y, or Z axis. Again, the same concept that we've learned on the bounding box, and also the partial grid. So the bounding boxes of each object is projected into the X, Y, or Z axis, defining the one-dimensional collision interval of each object along the axis. You can call the axis B1, yeah, that marks the beginning of the collision interval. And then the axis EI being the end of the collision interval. So this one then will work in a game where we have very many objects that are moving in various directions. So two objects whose collision intervals do not overlap cannot possibly collide with each other, because along their paths, you cannot see any collision within the paths. Yeah. So there's no possibility of collision. And then the two objects, then we mark the two objects are intersected into a list of the two entries. Then the list is sorted in an ascending order. So you can have very many objects that are moving within the game scene. So what we are saying, we are just projecting these movements within the X, the Y, and the Z axis. And then testing the projections of whether they're going to intersect or not. So we need to have the beginning axis and the end of the interval axis. And then now you test these two objects interchangeably. You can have many objects. Yeah. And so for each object, you need to test the interval of its movement and the beginning of the axis and the end of the axis. Yeah. So when you have very many objects, then you will have to place very many objects within there. So you have to create an array of all these collision detections algorithms. Yeah. So basically how it works, sort all the objects into their maximum X coordinates and Y coordinates. Then keep track of the current X coordinates as we keep moving the objects. For each object at the current X coordinates, check for collision with the other objects already within the current range of movement. Yeah. Then you add the object to the list of active objects, then remove the objects from the active list if their maximum coordinate is less than the current sweep coordinate. Yeah, which means you remove them because there is no likelihood of collision. Then now you create an array which will now create the repeating sweep and sort. So you sort, then you sweep, you sort, then you sweep repeatedly. Yeah. So this one you can achieve it by programming it. You can program it in either Python or JavaScript or even C++. Or you can even import the functions, because most of these game engines come with already predefined functions, like the functions for collision detection. You can just import it from the library of predefined functions. Is that okay? Any question about collision detection? Okay, so I don't know whether we'll talk about event listeners because I want to give you chance, maybe those who are presenting. I already have your mark sheet, but I'll be sharing with you your marks on the Google Class. So I want to give 2 minutes to each person just to present to us his or her game. Uh, Start by telling us your game story, which engine you've used to develop your game, um, what is your end game or what is the objective of your game. And you can also tell us what are your target audience, where do you want to, what do you want to do with that game, what is the future of that game, have you developed it for commercial purpose or just for leisure, and then we proceed. So I want to float these minutes to you. Who wants to begin? For those who had presented, if they are finished, you can also show us what is your end game now. So we have 17 minutes. The faster you move, the better. Ama, you are still in the kitchen, perfecting your games. Adoma, you should tell us what you've already done or what you're intending to do.
I am building a platform game, but I've not finished. I was choosing the engine.
Mhm.
Yeah, I should be done by the next class, either Monday or Friday, the one that we'll have.
Okay.
Yeah, so I'm still looking for textures.
So, so I think then if we don't have anybody presenting, then we can look at our event listeners. Oh, somebody is ready. Wisdom.
Yeah, I have a game I've been working on. I can present.
Okay, good. Go ahead. You can share a screen.
Mm. Okay. So far, what I have worked on, I have managed to do. Okay, it's a repeat of the previous Flappy Bird game that was initially there. Sometimes this is just now I've changed it to a ball, and as you can see, you can control it to you can control it. I've managed to put a score system, a distance system, game over tile, and several other features. Yeah.
Okay. So your game story is that your ball should not hit these pillars.
Oh yes.
You have to try as much as possible to pass through
And
all
it's
the pillars. What about the clouds? What happens when you hit the cloud?
the clouds are just random background that I've set up to add some variety to the enemy, to the game itself. Otherwise, they have no effect on the player at all.
Ah, good, good. So it's just basically to create a game environment, and so you get you. So your end game is to garner as much points as possible, right?
Yeah, it's one of those infinite games where there's no particular end goal. You just get as far as you possibly can to get the highest score in the game. Perhaps later I'll add some features for a high score system and a leaderboard.
Great. Yeah, that's nice. I think this is a good game. And I've seen it's applying a lot of concepts that fundamentals that I've learned in class, including collision detection.
Yes.
When it hits the pillar, it falls and you lose. So that is a collision
Also,
detection. Yeah.
also when you cross the screen boundaries, it also ends the game.
Okay. So when does your game end? Or it's an infinite game?
Yes, it's an infinite game.
Okay. Sawa. Thank you so much. Any question on Makoha? Good. I've seen people clapping for you. So this is an interesting game where the player has to be as alert as possible. I've also seen the element of event handling where you hold the key. Is it, I don't know whether it's a space key or an arrow key to keep the ball afloat. So those are the things that we'll be learning on event handling. You want to present again? Okay. Anybody else? Thank you so much, Wisdom Makoha.
Okay.
You can share with me your particulars, your registration number, and when you develop a game, also develop document your game so that somebody can read even without playing and understand what your game is about, because that is what we're going to file. That's what we're going to mark. Even if we have awarded you the marks here, we'll have to go through your document and file it here. So thank you so much, Wisdom. Anybody else? Yes, Dominic.
Let me present my screen. I don't know if you guys can hear me. Can you hear me?
Yes, I can hear you.
Okay. So this is my idea.
Do
Developing a game
yourself
on Unity.
Mm-hmm.
Okay, let me try increase the mic volume.
Just proceed. I'll try to listen. Yeah, good.
Okay, yeah. So I'm trying to build a game on Unity inspired by a game that Google once made. You know, usually when the guys at Google have some spare time, they like to build fun games like I don't know if you've seen Pac-Man and the likes, Snake. So during the 2022 Olympics, they created this game that was supposed to be. Uh, let me just mute it for now. So in this game, you are a sprite, a fox that runs around Japan. No, I think it was China. Yeah, and you're walking around, walking into rooms, and inside those rooms there are tournaments that mimics the ones that are happening in the Olympics. So like you could walk into a room that has table tennis going on, then you're playing against somebody. You could walk into a room where they're having like a skateboard type game. So you see, like when you go down through the wall, you get to experience that thing. Although right now I'm very far and the world is very huge, so it might take me a while to get to a room, but you can see like the environment and stuff like that. So this is what I'm trying to get at, but of course not as complex. So right now, like if you walk into that place, yeah, you're able to load a different section and play rugby. Like right now, this is rugby. Yeah. So enough of
Okay.
that. So my game is pretty much the same. Trying to build a wild environment. That this is not too small, you can see, where the player can also walk around and interact with a room and maybe do something in that room. I haven't really putting into what I want the player to do, but that's the idea. So right now you see the player can move with WASD over script, and there's some collision physics as well. Like you can't walk through the base of this tree,
Okay.
but you can go under. Like that now you're going under. Also, there's some load utility. When you get to a door like this, I put a game object that's supposed to load you inside the house, but currently that's a bug that I'm trying to work out and it's not working. But my
Okay.
main focus on the moment is Unity has some really nice thing called tile sets. So I'm trying to build a wild environment. It's really easy to draw. Like let's say I wanted to put some pool of water here. Like once you make the tile map and just draw, already you're creating an environment. And if you want to make a path to it, really easy. So
Yeah,
once I
good.
finish, yeah, some wild environment, when I'll handle now the game logic kabisa, yeah, going into rooms and doing some activities. So that's pretty much where I'm at.
Yeah, that's great. Thank you. It's a very interesting game. Longing to for you to finish. So as you can see in Unity, you can do a lot with already assets that are already there. You can play about around all those assets. You create anything that you wish, then you create the conditions or you import them. So yeah, thank you so much, Kimeu. And yeah, let's move with speed and finish. Good. So yeah, thank you. Seeing number 142, 580. Yeah, anybody else? Let's move with speed. We have 6 minutes. If you can have two people sharing the 6 minutes, I'll be happy. Who wants to go first? I have a hard stop at 10. Where are the others? Rahma. Okay, Jeremy. Rahma, you should present next class. Jeremy, go ahead.
Am I audible? I'm trying to share my screen. Okay. So basically, I just have a sketch, like a skeleton of a platform game with a few sprites I was working on. And wait, I think I need to share my entire screen. Let me. Yes, that's much better. So basically, I used GDevelop. It's a drag and drop type of game engine. It lets you kind of just drag stuff around to write commands for your games. So if I preview this, I don't have too many mechanics in place. I hope it's visible. It's just this sketchy guy who can move around, and he can now, for now, jump on platforms and get to higher levels. My idea was to copy something like Doodle Jump, where you have like infinite platforms going to a certain place. But yeah, so far, this is just the sketch of the game that I have.
Okay. Like poker, parkour. So what is your game story?
Yeah, kind of like parkour.
What is the story of your game? I didn't get that clearly.
Okay, so basically, not too much of a story, but experimentation with the platform. I was just trying out this GDevelop so that I can see if it's valid for me to express my ideas. The actual idea for a game I have for the semester is an asteroid game, like the one where you have a spaceship and you shoot around. But I just
Okay.
want the engine to be diverse enough for me to actually do it.
Great. Thank you.
Sure.
Anybody else? And thank you for taking the precisely 3 minutes. Somebody else? You can even share with us your ideas. Okay, thank you so much. So let's meet on Thursday. Thank you. 42 to 7. Let's meet on Thursday then. Hope we'll not have some funny holidays. For those who have not worked on your project, please do it. Let's move fast because we need to do a sitting cut like in 2 weeks from now. Then now we start working on our exam. Otherwise, thank you so much and enjoy the rest of your day. I'll share with you the slides if I have not shared. Then we meet on Thursday. Thank you. Good day.